can we go to the next slide, please? Yes, so this introduction or this talk is about the NanoSafer tool, which is a combined control banding and risk management tool that is made to enable assessment and recommended management of the potential occupational inhalation exposure risks associated with production and use of nanomaterials. Next line. So the application area of the tool is basically solid, so it's nanomaterial particulates. It's able to handle or assess exposures and risks during powder handling, but also transfer as well as diffuse and point sources where the process release rates can be estimated. For example, you can assess or you can estimate that you will lose maybe 0.01 weight% of a process or transfer to estimate what could potentially be the exposure levels and the risks. And the tool overall is predictive in the sense that you try to do quantitative assessment, but these are all ranked in the exposure modeling that you will see later on. We also work on pending methodologies, the mechanical reduction spray with stable solid ingredients. But since our system here is based on emission rates, we are building up the data libraries in these aspects, and we are soon ready to give a first go on that area. Next. The users intended for this tool is really supposed to be at the workplace. So it's occupational safety managers, the worker representatives, who will be able to do their own nano-specific workplace safety assessment. We've also found with a dialogue with the authorities in Denmark that the inspectors who assess the workplaces would also be interested in using this tool, but also have the result of this tool as a basis for a dialogue between the industry and the inspector, and can also be used to, for example, understand whether the risk management measures that are put in place are suitable for the exact or the specific work scenario. And finally, of course, consultants are also a target for the tool, and can also be used as an first state tier 1, tier 2 level of assessing the risks and the management that is required for this specific situation. Next slide, please. So the workflow and information requirements to use this tool is that we expect the users to have a product data sheet with key information about the material. We expect them to have a material safety data sheet, which is, of course, required in any case with chemicals. And we are also well aware that this material safety data sheet can be on the bulk material, and this is the way that the system is designed, that it is per default considering that the information that comes on hazard are actually from bulk materials, but there's also a possibility to actually enter nano-specific data if that should exist. And then, of course, you are expected to know the work scenario that you're going to assess, and that should usually be possible in any production facility as well as in the lab, because you know personally quite well what you're supposed to do in the lab. So the process is that you, of course, log in, you enter your material data, and then after that there will be an assessment of the whether this material has nano relevance, whether it complies with potentially being a nanomaterial. If it does not, it can be possible to do a normal risk assessment, but you can also continue using this tool where just the nano-specific precautionary calculations will be taken off. Then you enter the material safety data, including the exposure limits, if that's the case, or specific nano exposure limits, if that's the case. Also, if you have a target value in your factory or facility, then you can also use that value instead. Then you enter the activity and contextual information for your workplace situation, and this is all stored in a personal database. And then you go to the assessment where you can select the nanomaterial or process that you are working with, and then you calculate, or the tool calculates the anticipated hazard levels and the anticipated exposure potential and scores this to give a combined control banding evaluation. And this is then the risk evaluation output. And then you can go further to that and go to e-learning and good practice in risk management if that is required. Next slide, please. So the time to conduct an experiment, if you are highly experienced, you can do an assessment in about 10-15 minutes. And if you don't, well, of course, depending on whether you actually have the data, but if you have the data available, then this is the time required to use the tool. And we saw that in the early phase, some users spent half an hour or something like that to go through the system. So I expect that the normal use will be in the range of 15-20 minutes probably for one assessment. Next slide, please. So the hazard assessment paradigm follows pretty much the same conceptual idea as Stoff Manager. We have an assessment of nanorelevance, or I should say that the overall idea is that you group and scale the hazard potential based on physicochemical properties, the occupational exposure limits of the analog bulk materials if there's not a nanospecific data, and the hazard or risk sensitiveness of the nanospecific of the bulk material or the nanospecific occupational exposure limit. And the assessment follows an evaluation of the nanorelevance, and again, if it's soluble in water, as also in Stoff Manager, we say that traditional risk assessment can be done. Then we evaluate whether the material is a high aspect ratio nanomaterial and complies with the fiber paradigm of WHO. Then it will be a high hazard material immediately if it's both insoluble and a fiber. Then we have an assessment on, or a question on, whether it's surface chemically modified. If it is, we add a risk potential or hazard potential to the material, because we have seen in some cases that coatings can increase the hazard of a material, whereas in other cases it can reduce the risk, but in most cases it is not known whether it affects in a positive or negative way. So unless that this is known, we put in an additional hazard level to the material. And then we ask whether the analog bulk material has a high or low exposure limit. Here set as a difference on where the difference is 1 milligram per cubic meter. If it's above, then we consider it as a relatively low hazard material, and if it's above, we put them in the higher rank materials. And then we make a calculation based on the risk phases or hazard phases of the material and come up with a final score, which can be between 0 and 1, where 0 is or 0.2 is the lowest toxicity, and 1 is the highest toxicity that you can achieve. Next slide, please. The exposure assessment is conducted doing a two-box modeling based on the input parameters, and we consider in the exposure assessment whether you are in the near field, so close to the source, or in the far field, further away from the source. So the calculations of the exposure is taking acute exposure and daily exposure into account. So acute exposure is following the rule of short-term 15-minute exposure, where you are allowed to be at an exposure level of 2 times the daily exposure level, exposure limit. And the daily, of course, complies with the daily exposure limit. And for the assessment, we calculate a nanospecific occupational exposure limit if it does not exist. And this is based on the specific surface area and density of the material. So you can say we, in fact, actually calculate a volume-specific surface area exposure limit of a material, and also calculate the exposure in surface area exposure. So we use this to take the nanospecific properties into account as a basis. Next slide, please. So when you have done an assessment, there is a direct assessment available on the web, but you can also print a PDF of your assessment, and this is an example of the PDF of a NanoSafer control banding report, and again focuses the airborne occupational exposure. You can inform or put into the sheet information on who you are, and then it will automatically fill out the fields that you have entered on the web tool. So what type of material it is, the name of the material producer, etc., etc. You also have some key information about the estimated hazard. In this case, it's 0.2, so the lower hazard range. And you also get information on the volume-specific surface area and the occupational exposure limit that was used for the analog bulk material. And then finally, you have here a time-resolved estimated exposure index, where you can see in this case we have 5 repeats of an operation that gives a near field and a far field exposure potential, and down here you have the score of the exposure. So we see that we are close to 0.6 of the acute exposure limit, and in the near field, and little less than 0.2 in the near field daily exposure limit in this case. And the control banding comes out with that we have a relatively high exposure potential in the near field acute and a lower exposure potential in the daily exposure, and moderate for the far field acute and low in the daily exposure. And then over here you have the individual assessments on a green to red scale, the near field acute 15-minute exposure and the daily acute near field and far field exposure here. And then there's some recommendation on how you should, what level of protection you should use here. And this is shown in numbers down here. If you put on the next slide, Claire, we see that based on the estimated hazard and exposure potential, it is recommended to apply engineered protection equipment with a protection factor of almost 6. And then we refer and we'll link up something called the eCell library that was developed by the TNO, but which has the performance of a large suite of engineered and personal protection equipment that you can select from and then design your work situation or protect yourself in the work situation as best possible. And then we of course refer also to the exposure management and e-learning tool on guidance. Next slide, please. So this is the guidance, the inspiration tools. We have 3 different types of information. One is introduction to the control hierarchy that you probably know very well. So you go from elimination, substitution, engineering controls, and administrative controls, and then finally to the personal protection equipment. And there's some general guidance on personal protection equipment, etc., that is given as audiovisual information. You can also get inspiration for exposure control by going through different steps in the factory, including cleaning and also cleaning, etc. So what you should be aware of. And then there's also some pamphlets on specific work scenarios. So this, for example, is inspiration for laboratories in this pamphlet. So next slide, please. Yeah, that was it. Thank you very much.